So hi everyone, my name is John Sutherland. I am the head of the new School of Sustainability Engineering and Environmental Engineering. And I have the honor to introduce our moderator for this panel session, Natalie Stofflet. She is a PhD student in the School of SEE here at Purdue, and she has a master's degree in environmental ecological engineering from our department and dual BS degrees in hydrogeology and environmental and sustainability studies from Western Michigan University in beautiful Kalamazoo. Prior to coming to Purdue, she worked as an environmental consultant. She focused on site characterization and remediation for 8 years. Natalie, enjoy your moderation.
Thank you so much for the warm welcome. So we just heard a wonderful lecture from Dr. Jambeck centered on reducing plastic pollution, and we now have the opportunity to continue this conversation through today's panel discussion. So our panel discussion is titled Multifaceted Challenges of Plastic Pollution and Possible Remedies. So at this time, I would like to take a moment to introduce each of our esteemed panelist members. We are pleased to welcome Dr. George Zhou, an associate professor of civil and construction engineering with a joint appointment in sustainability engineering and environmental engineering at Purdue University. His research focuses on water quality, wastewater treatment, and environmental microbiology. Next, joining us is Dr. Linda Lee, a distinguished professor at Purdue University with joint appointment in agronomy and sustainability engineering and environmental engineering. Her research focuses on environmental soil chemistry, including the fate and remediation of contaminants such as PFAS and other emerging compounds of concern. And we also have Dr. John Howarder, an associate professor in materials engineering at Purdue University with a joint appointment in sustainability engineering and environmental engineering. His research interests are centered around recycling the operational energy footprint of separation processes used in treatment of industrial wastewater, including PFAS-containing wastes and residues from semiconductor manufacturing and value recovery through recycling and reprocessing of waste materials from industrial processes. And of course, we have our distinguished lecturer, Dr. Jenna Jambeck, a Georgia Athletic Association Distinguished Professor of Environmental Engineering at the University of Georgia. She is a global leader in plastic pollution research whose work connects science, policy, and citizen science. So I will now just take a brief moment to explain the outline of today's panel discussion. In a moment, I'll invite each of our panelists to spend a couple of minutes describing their connection to today's panel topic and their perspective on how it relates to their research and interests. After that, I will pose a series of questions to help guide our panelists' discussion as they engage with one another. So without further ado, if we could have Dr. Zhou please start us off just by sharing a brief connection, maybe 2 minutes or so, with today's topic.
All right, thanks for the opportunity. The talk you guys have heard is amazing. So when I tried to download the application, I saw there's so much data, and it's extremely impressive to improve people's awareness about environmental pollutions. So as an environmental engineer working on water, wastewater treatment, I always trying to help to improve the quality of life by tracking the contaminants. And I have been working on antibiotic resistance, and there are also studies to show the plastics actually promoting the transfer of horizontal genes to cause additional health risks to humans. And I also have been thinking, for example, this is a very complicated issue. So I have been working on the treatment systems. We have to deal with regulations, and we have to deal with treatment technologies. So I'm also thinking if this plastic pollution issue is more related with regulation, or if it should develop maybe bioplastics that could degrade easier, or it could be just a awareness issue. So I have lots of questions, but I really enjoyed the opportunity to listen to you, to learn the great stuff you have been doing.
Thanks, George, and thank you for that great talk. I'm very passionate in this space about reducing plastic use. In fact, I'm a Hilton's Honors member, and they always give you 2 bottles of water. I said, I don't want them, thank you very much. So I try really hard to always have my aluminum can water bottle. So I'm passionate about that, both because I'm an animal lover and I know what damage it has been doing in the environment. But from a research perspective, I'm interested in both how PFAS can leach off some plastics or and other what we'll call unregulated organics, phthalates, and we've all heard of BPA-free. Well, a lot of plastics contain these organic contaminants. And then if they don't contain them, they can sorb them when they're floating around out in the ocean. So then when our wildlife then ingests them, they're not only being punished by the plastic that's not giving them nutrition, they can also release these contaminants back into their body. And I think it's particularly, I think about the whales during the winter months when there's not as much food and they're losing body fat, and then they have just a belly full of plastic and contaminants that are coming off the plastic, either because they were used to make the plastic or the plastics captured them while they were floating around in the environment. So I think that I'm all about what can we do at the front end. We're trying to deal with this at the back end, but as Jenna said very well, we really need to be dealing with this at the front end. And until we have some type of regulatory framework or incentives to encourage people to be more mindful and be good stewards of the only planet that we have, we're going to continue to run into this problem, this challenge of being able to reduce it. So thank you.
Yeah, thank you both, and thank you, Dr. Jambeck, for being here. It was a great talk, and my introduction, I'll give a little bit of an origin story. All of my degrees are in materials engineering, and when I was a grad student, I was focused on polymers, polymer systems, thin films, coatings, and it turns out the work that the material system I was working on turned out to be full of really toxic chemicals, and most of that stuff got banned shortly after I graduated. And that was part of a bit of an awakening for myself in thinking about, as a materials engineer, we're often tasked and proud of inventing new materials, inventing new systems to use materials. But I think during my postdoc time and then coming here as a new professor, I really challenged myself to think about the whole life cycle. So the theme of circularity, I think, is something that I like to bring into my own work, into my own lab, and thinking about when we're designing that new material, what is the actual end of life? What is the fate? And I think as the designer, as the upstream designer, we have a lot of control over eventually where that ends up.
Am I on? Yeah? Okay. Yeah, well, I'm just excited to be on the panel with all of you, and I love that we had breakfast together, too, to kind of start some of these conversations. You're not the first materials person who has been inspired to change by by this research. So one of my colleagues at UGA, who then started the New Materials Institute, we started that together specifically to think about end of life at development stage, because it hasn't been a component, especially in materials curriculum, right? There's just literally no what happens to this material after someone throws it away. It's
right. It becomes a product, and then it's like mission accomplished.
Yeah, exactly. So I think that thinking is so important, and it's so awesome that you're thinking that way. And then PFAS, is such a big topic with alternatives. So we have a lot of folks. I think that I would love to dive deeper into that with you. Thinking about, yes, now, they'll get the paper board or, more of a paper material, but then it has to be coated. And I think they're almost always coated in something, either PFAS or PFAS-like. So I would love to hear your thoughts on lots of people are coming up with alternatives now, but if they're paper-based or fiberboard, how do we make those grease resistant or whatever without that? Anyway.
Yeah, actually, that's really interesting. The states that have moved ahead, obviously ahead of our federal system, they have certain criteria. And so the state of Washington was the first state that made any regulation plans for PFAS, and it was in paper-based packaging. And in doing that, so I presented to them so Zero Waste Washington was quite proud of zero waste. And then they contacted me and they said, we think we've created a huge problem. We didn't understand about PFAS in all these papers that we're composting and then land applying everywhere. And so what they did, they got me, I don't know, a dozen or so of composted paper materials from across the nation, so I wouldn't know where they were going, where they were from, and did PFAS analysis on them. And then I made a one-sheet fact sheet that was presented to the representatives in the state of Washington, and that fact sheet led them to propose a bill to regulate out PFAS-coated paper packaging, fast food packaging, the whole gamut, by a certain date. But they had criteria, and it was that the replacement had to be within 10% of the cost of what PFAS were. The replacement had to be available in the supply chain. The replacement had to be able to be used in current manufacturing processes, and the PFAS, or the replacement, had to be non-toxic, and that's always tricky, non-toxic to what, but that was, and then there was a fifth thing that I never can remember off the top of my head. And it turns out that within less than a year and a half, they were able to identify 75% of the paper-based packaging and plastics that people use for to-goes could be made without PFAS and could fit all the criteria that I just defined. So there was only like 25% that were stuck. And believe it or not, one of them was the clamshell. They couldn't, get that at that time produced without PFAS. And it's complicated, as I learned from Dr. Youngblood here, it's complicated because you can end up creating something that's stain resistant, oil resistant, but what you created now doesn't have the right structure and can't hold the food. So things you don't think about. So I think when we're talking about plastics, it's the same thing. We need to have criteria, and we need to move very aggressively towards achieving that. And it's frustrating that, especially in the state of Indiana, we are so proud of our manufacturing and innovation, and we're doing everything, the regulators or the state, the legal aspect of our state, they want to bring industry in, and they try to come up with all these incentives. And I had met with them the year before COVID and said, we have an innovative workforce, so give industry incentives to replace PFAS before it's a big thing, and let us take the lead as a state. But they seem to find it difficult. I'm like, well, you give tax incentives left and right. Let's give tax incentives to companies that are going to find alternatives that are safe and meet the criteria that I had described. And so I just think we need more of that attitude.
Mm-hmm. I'll let you take over in just a sec. I just want to follow up on one thing you said, which I love, and I think it's so good for engineers to hear, and I think we excel at, is put in those constraints. I love that you name, it needs to meet this, those 5 criteria. And guess what? They found things. And if they hadn't, someone would probably invent them, right? Like, I love that, put those constraints in place that we feel like we need to, make the system, create less leakage, prevent leakage. And then I think we can engineer within that system.
Wonderful. Well, that's an excellent segue into our first discussion question, which is, what is one policy change that you would like to see on a local, state, or even federal level that would change how plastic is used, created, or treated at end of life? Dr. Jambeck, did you want to take a start at that, or do you want to round it out?
I can start. I think I kind of answered this even in one of my the student that asked the question about how do we build up our recycling system. Certainly a national extended producer responsibility law would probably be helpful even for companies, because now they're going to get a patchwork quilt of policies throughout the U.S. with states, doing different ones. But even, as I said, the deposit return scheme on bottles, which in Norway they had both EPR and a DRS, which is the deposit return scheme. Those together kind of created the magic recipe for like a 99%, 98 maybe, recycle rate for PET bottles for example. So I think both of those policies are ones that I've talked about and told Congress I think would be helpful for preventing leakage.
Well, I love the extended producer responsibility answer, and I'd be remiss if I didn't bring up that Mitch Daniels actually signed one of the first extended producer responsibility bills for e-waste in the state of Indiana. So it's a concept that's been around, and it's a concept we don't have to be afraid of, right, in terms of policy. I know sometimes people don't like change. You know, the other thing that I think is at the front of my mind, though, is, you know, I think on the local level, you know, I think we can actually be more judicious about what we're choosing, right? And this morning when we were having breakfast, we were noting about the water bottles. We all noticed when we sat up here, there's water bottles under our chair, right? And you know, I mean, there's alternatives for how we transfer even our single-use beverages, right? And I won't dictate what that could be, but, you know, as a materials engineer, aluminum's been around for a while, right? And it doesn't have to be this plastic. I will notice, though, that in the trash that you showed in the Mississippi River, there's still a lot of aluminum cans.
I know.
So it's not a one-size-fits-all solution, right? Might be whack-a-mole, but.
Well, that actually made me think of one of the things that we oftentimes run into, and I have a lot of examples in trying to now minimize plastic waste. We run into other things like, you know, we used to get milk in bottles, and then you take your milk and you can go and refill, and then that became, you know, it just not just inconvenient, oh, that's too much transport, and now we're creating greenhouse gases. So what you oftentimes see when we're trying to address problems is everybody has their passion and we don't all talk. And so then we create problems, you know. MTB in gasoline was one of those problems. You know, don't put MTB in gasoline. But the air lobbyists wanted clean air faster, and they gave them 6 months to find something to get let out and something else in. They did MTBE. That was not the right solution. But we weren't all talking because we each have our passions, and then we don't listen to each other. And I think that that's also what we face with the plastic problem. Yeah.
Well, when we talk about policies, rules, regulations, guidelines, I mean, they all are different, and we have a lot of barriers. For example, if you put a new regulations or laws, I mean, it may be very time-consuming, but there are some local policies, maybe at the university level or city level, that we could do. For example, to encourage recycling, to put some penalties for those who, you know, dump plastic or cigarette butts. However, I do have a concern because if you only put a fine, like the rich people can buy out, right? But the pollution will affect everybody. So I do have an alternative suggestion, which is like you put them in a community service. Just put them there and let them spend their time so everybody will become more aware of the potential issue on the community. We can do that in the university, we can do that in the city. And as long as we're concerned about sustainability, I think we could very small steps, we can do something like this.
I really like George's response about community service. It's true. And, you know, Purdue, they use PFAS-free paper products in Purdue Dining. They started that a couple years ago. So, and they're moving in that direction. So we can start local and then global.
Can I get a couple things now? I want to react. So the community service part, I've definitely been, I haven't ruined anyone's life, but I think we are sometimes blind to the leakage that's out there, right? So we have like these first year Odyssey courses. Anyway, I usually find any reason in my course to go out and collect debris tracker data. And most of the students are like, I had no idea this was even here. Like I never saw it before. And now, then they actually collect the data and see it, and they're like, wow, like this is, you know, super interesting. I can't unsee it. And I'm like, sorry. Now you know what I feel like everywhere. But yeah, so I think that has an impact. And then the other thing was about local. So UGA doesn't allow expanded polystyrene, or what we often call styrofoam, which is not, it's a different product, but expanded polystyrene on campus. So Chick-fil-A, which is one of like, that's their like iconic thing almost, or I don't know, iconic is the right word, but they're known for the styrofoam cup and their ice, and they're not allowed to have them on our campus, so that's great. They did, guess what? The policy's in place. It's not like they went away. They didn't go away. They just changed their cup.
Yeah, that's wonderful. And that actually segues into my next question. I want to take it more to a positive note, because I feel like when we hear about reducing plastic pollution and recycling, sometimes we hear more about the challenges that are associated with that, rather than what's going well. So from your perspective, what's a component of this challenge where you feel like we've made progress? Dr. Lee, would you like to
Well,
start?
I'll just say the story I was telling Jenna earlier today is, when they started, when I asked an audience if it can be in the wastewater engineers, it can be sewage people, how many of you know something about PFAS? And out of 300 people, I might get 3 hands. But if you ask them if they know anything about plastics or microplastics, most everybody. And so I think some of the National Geographic videos that have gone out, the movies that show the swirling plastic in the ocean, there are people that I have had to agree to not have a conversation about recycling because it gets them so upset because they don't want to recycle. And then those people were changed when they saw those kinds of movies. So some of those documentaries can be very powerful. They don't have to be long, so they can be very powerful to change behavior. So I have seen people that are about a decade older than me that were set in their ways. Recycling is just not, that's just a waste of time. They don't do anything with that. And all of a sudden to go in their homes and see that they have recycling bins, that's exciting. So that's a positive thing, because it is, when we make it known and we do it in a very creative way that is not so offensive but more emotionally touches the emotion, we can see change.
This is a very hard question. And the thing that is on my mind is that I think in my lifetime, a lot of companies have been better at listening to their customers. And you mentioned something in your talk that we're limited by the choices that we have in the marketplace, right? And if I want to choose an alternative packaging material, well, I'm still limited by what's available, right? And I think we live in an era now, whether it's because of social media or smartphones or just the way we communicate with each other, that I think customers are probably more empowered than they were when I was growing up. And I think that's a lever that we can use for positive change. Now, that also means that we also create things that are maybe also detrimental to the environment, so it cuts both ways. But I think if we have informed consumers and companies that actually develop a relationship with their customers, I think you can see positive things in that direction.
I completely agree. This is a very challenging issue, legal issue, political issue, cultural issue. I think the most effective approach is the policy. But if you consider the case of perchlorate in the EPA's contaminant candidate list for so many rounds, and it's eventually removed because of concerns, of financial concerns. It's an issue, serious issue, but only occurs within a small fraction of utilities. So I don't have a good solution, but in the ideal world, I think one of the main challenges is that it takes a very long time to break down the plastics, ranging from 10 years, or in the landfills could be up to 500 to 1,000 years, right? So if we have maybe as an engineer, if we have some innovations to design the biodegradable plastics, or material scientists, right? So it's no longer causing this long-term issue. That might be a solution, but I consider this will be a very challenging technical barrier to solve this problem. It's one of the elements.
This is a hard question for me because I have so many answers, actually. Because, working in this space when it wasn't even a space, it's like, wow. Yes, it's very complex, and it seems like, how do we, we're not going to get rid of all plastics, and, yes, we're limited by what's there, but all the things you've said have been positives, and there's even more. Just the fact that there's an entire panel at Purdue talking about this issue is a huge step forward from just 10 years ago, right? So to me, I've seen so much progress in the last 20 years. what I hope is that we can keep this momentum going and just have incredible people like you all involved and thinking about it. It's just magical for me to sit here and hear you guys talk about it, honestly. So there's a lot of positives, and I think we just want to keep the momentum going.
I love that. So I've heard this come up a few times now in our discussion about responsibilities for industry and driving meaningful change. So from your perspectives, what does that look like? Is it material innovation? Is it waste reduction? Changes in production practices? What would it mean to actually design these solutions?
Well, that's hard, but I think it's all of those. But I think John said something that's really key, and it's the power at the cash register, really. Consumers have a lot of power now in data science. And I think about when some of the antimicrobials that were only used in hospitals, and then all of a sudden they got permitted to be used in everyday products. And then we're finding out that they do degrade, but not for a long time, very persistent and toxic to aquatics. Well, it's interesting when you look at the wastewater influent and effluent, what was coming into the wastewater treatment plants, so more influent, that these two in particular, triclosan and triclocarbon, their levels started to decrease before regulations changed, because consumers started thinking, I don't need this in my product, because, if you're good at your job, you're good at your job. If you're good at marketing, you're good at your marketing. You've convinced everybody that they don't want their bar of soap sitting in the shower with all this bacteria on it. We know as scientists how soap works. It kills the bacteria. But no, they market it very well. Buy our soap, and it's got antimicrobials. It doesn't have bacteria. So everybody started buying it. And then it got to be in weight percent lows in even your toothpaste. It wasn't necessary. So people started to realize it's not necessary. And even before data science was as big as it is now, before they even regulated them back out of everyday products and limited them back to just the hospitals, it had already decreased in the effluent coming into the treatment plants. So I liked what John said, that industry is driven by consumers, and you have a voice both at the cash register and wherever else you can have a voice. And we have always proved to be innovative. We were not supposed to even have this many people on Earth. We were supposed to collapse because we wouldn't have enough food to eat. Well, little innovation took us a long way, also created more pollution problems. But the point is, we are innovative, and that's where you have to make the people that you rub shoulders with know that what they do counts, because we think it can't count. We're just one little person, but it does. It adds up and it counts. And that can drive industry, because they're all about profits and they're all about sales, right, in the end.
Just a personal experience, I noticed one of the major online shopping vendors, I will not name it. So they start to replace the packing material from plastics to paper boxes and envelopes, paper envelopes. I think it's a really promising trend to actually replace from smaller steps. And I don't know if there are actually channels to provide feedback, but when I renew my membership, this is something I probably can provide the feedback, because I think this is helpful to address, really smaller step to address this issue.
I think a lot about recycling and the supply chains related to recycling, and in a lot of systems, the person that's recovering the value at the end of life is not the producer, which is why I get real excited when extended producer responsibility gets talked about. But in my house, I do all the grocery shopping, and the thing that is very obvious to me is that everything that ends up in my recycle bin, whether it gets recycled or not, like 90% of it came from the grocery store. And I go to the grocery store every week, and I go there with an empty trunk. Maybe I have some bags that I'm recycling, but that's the only thing my grocery store takes back. And my recycle bin is clean, because we have the packaging stuff, we rinse it out because I don't want it to smell and whatever. And I just wonder if in some future fantasy world, there's a supply chain that actually exhibits the circularity, where those same trucks that are bringing things to the store are actually bringing the material back to the producer and saying, okay, here are your bottle caps. you figure out what to do, you know. Because even the deposit system, I mean, that we think of as being circular, but it still has aspects of linearity in it.
Yeah, that's interesting. Yeah, I would say all of the above in what you mentioned as well. I think that there are some places, I think, in Europe that have a little bit of that circularity with transport. I think it is where they have DRS, though, actually, too, the deposit return scheme, where the trucks can also take the materials away. But I don't know if you've also heard the story of the folks in Europe who like unwrapped all their packaging, or they unwrapped all their groceries at the grocery store and left their packaging. It was actually a protest. You would have fit in very well with that protest.
Yeah, it would be very effective.
And so, you know, that is one way. I mean, I love talking about sort of the grassroots communications to change we have through the social media channels to tell companies, and that is often what I tell people, like, tell the companies that you're unhappy with this packaging. Tell your government that you would like to see more policies. But one thing I would like to see more of from maybe a top-down company, and they say they've tried these, but they don't work, but I do think we have logistic systems now for getting back to reusable systems. Like, let's not prevent waste in the first place. The packaging has value, can be reused, but I still see challenges in this. I wonder about PFAS. I've seen a lot of these black plastics, so I still wonder about microplastics. You know, can we do this without using plastic as the reusable material? I don't know, glass is heavy, but it is one of those, it's one of those that spins in my brain that I feel like we have the technology to do reusable systems well again, but I don't know what that looks like, and that's what I'd like to see, because I think that would help.
Absolutely. So I've heard this come up a few times now also, this PFAS and microplastics. I know you each have your own connection to these emerging contaminants. So how should we address emerging contaminants and pollutant interactions linked to these plastics when designing interventions and assessing their risks?
Well, we have this term emerging contaminants for at least for 3 decades. I mean, they're still they're there, but they have been there for, I don't know, for many years. So this also puzzles me. If you look at the history of the environmental pollution studies, from the disinfection byproducts, nanoparticles, DDT, right, in the very early ages, until PFAS, and you have nanoplastics, right? It seems like I always have this kind of issues. It always feels like when human society, you know, collectively is trying to develop something new, they are not aware of the unexpected consequences. So they design something with great functions without realizing the potential health risk, the persistence of all these issues, the negative adverse effects posed to humans. If you look at the nature, everything is recycled, right? So even you see, okay, we have swine waste, but it breaks down to nutrients, right? Nitrogen, phosphorus, utilized by microorganisms, by plants, and you have carbon recycled, you grow the algae, you grow the plant. So I just feel that for the human society, we should do better. As to how to get the better solution, I don't know. But I feel, I mean, that's probably the challenge for our young engineering students to develop a sustainable solutions, you know, to keep our society developed without compromising, like the definition of sustainable development, right? Not compromise the chances for our future generation. There are so many things we need to just look into, but I'm hopeful, right? Someday.
Okay, something came to mind. That was a very complex question. By the end of it, I was like, what are you asking? But I think, unfortunately, I have to say, in some regards, I don't know that we have all of the data to weigh the trade-offs and the risks, but maybe that's not the case. I love that, Linda, you said your MTBE example, people just weren't talking to each other. I think I've used that example before as an example of an unintended consequence, but I haven't heard that story told from that perspective where you said folks were pushing that through. Maybe some people kind of knew
The
that.
scientists told EPA, don't allow MTBE to go in the
Yeah.
gasoline. I found the documents because my
So-
major professor actually was on that scientific board to weigh in, but the lobbyists wanted it done and they wanted it now.
Right.
And so they were given like 6 months. And they had this in their back pocket all along, the industry did, but they knew that they probably shouldn't use that as the replacement.
Sure. Okay. So maybe that was not an unintended consequence, I mean, I'm sure it was no one intended that, but, we want to avoid those, if possible, of course. But sometimes I think if we don't have the data, then we're, an unintended consequence is one of lack of information. But I loved your statement of people need to talk to each other. So sometimes maybe there's more data available than I know. Of course there is. But, how can we maybe communicate better about this topic? But when we do get large groups of scientists together, so for example, we're working on the social cost of plastic for a working group out at NC's, and as we're trying to look at the impacts to humans and society across the production and use and disposal and leakage, it's absolutely overwhelming, and there's tons of missing data. At least that, we're aware of. So I think that remains a challenge to actually be able to, but then I don't like to say that because then people are like, well, okay, we can't do anything if we don't have enough data. And that's not true, because you can have the precautionary principle. You can be proactive, knowing that probably consuming plastics, every day is not good.
You stole my answer. No, no. But the last thing that you said, that precautionary principle. I mean, I think BPA was mentioned earlier, and if you were an adult at the time, BPA is what the reusable plastic bottles were, and it turns out this leaches into something that is kind of an endocrine disrupting thing, and it's a plastic, and there's a big freak out about that, and industry in its infinite wisdom, once that got banned, came up with BPF. Right, and we've got the whole alphabet at our disposal, right? And I think within our regulation space, there's this like middle ground that we are not accessing, where we are either banning things indiscriminately, without an understanding of what it's used for, but also not, the other end of that spectrum is saying we don't have this precautionary principle. Like when nanotubes were first coming out, people wanted to put nanotubes everywhere, and it's like, hold on a second, like, are we sure about that? And I think. Thinking about our products, whether it's durable plastic products or like personal care products, like, again, just like all the packaging I buy at the grocery store is going to end up in my recycle bin, all the personal care products I buy are going to end up in the wastewater treatment plant eventually, and I think as engineers, we can say to ourselves, what is this doing here? Do I actually need this? Am I over designing the product? And I think not only being precautionary in the chemicals we design, but also in how we formulate whatever we're calling our end product, our user product.
We know that the truth is that a lot of this comes down to money, but I just thought of a positive thing that money has driven. I mean, I travel a lot, and if you travel a lot, you've noticed that very few hotels anymore have all the little plastic bottles for you, like your mouthwash. Now they have big bottles that they fill, that they stay in the room and they fill. You don't have plastic waste. And I think in the long run, a company who came up with the idea, and it might have been because somebody in the company had a passion for reducing plastics. They marketed it in a way to show that, listen, in 2 years you're going to have saved money because you don't have all these plastic things. And I was always like, okay, I should take them home because then I'll give them to the homeless or whatever. Otherwise, they're not really supposed to leave them in the room, and they reload. So the leakage just is huge. But now almost none of the hotels will have anything but the fillables, where you just, squirt it out and somebody will fill it back up. That's encouraging. And it probably was driven by a combination of somebody's passion to reduce plastics and marketing and money, right? So.
Another win, I think, in this category that something you said reminded me of is the Microbead Free Waters Act. So just thinking about when you're talking about whatever personal care goes to the wastewater treatment plant, I mean, the fact that we had made little tiny plastic beads and put them in our personal care products, all kinds of personal care products that were going directly to our wastewater treatment plant. I don't know, I think they said that the plastics were good for exfoliating. I don't know if better than the natural materials, but it felt like one of those uses of plastics that were not necessary, and that's why that act pretty much sailed through our Congress. So anyway, and a lot of people fought for that and had a lot of data to back up why we needed to have that act. So that's definitely a win.
That was a great insight. So in that vein then, are there especially challenging plastic wastes or compositions that should be singled out for either additional concern just based on the risk that they pose to the environment or other factors, those that we should be moving away from?
Well, I will say, John brought the BPA back into the picture. When I've looked at what's in wastewater and what's in solids from wastewater treatment plants and what happens during some of the more advanced treatment processes like thermal hydrolysis, what shoots to the roof? It's phthalates. And it's from, phthalates that are in plastics, and they are known endocrine disruptors. And they're just really, they're orders of magnitude higher concentrations than other contaminants of concern in the materials coming out of the wastewater system. And people want to reduce pathogens, and they implement thermal hydrolysis, and then the phthalates even go up further. And it's probably because the elevated temperature is literally dissolving some of the microplastics, or it's at least causing, the desorption and dissolution off of them to be very fast. And so I think that they're, just like we got rid of BPA, although the substitutes also had a BPA backbone, but they weren't BPA. And they were also found to be very similarly toxic, but it's what we replaced them with for a while. I think that the endocrine disrupting materials that are used in plastics, that would be where we'd want to, because that can affect both humans and wildlife and aquatics.
So if I could jump in on the phthalates, for those in the audience that aren't familiar with it, think about the plasticizer in your car, the new car smell that you're having, a lot of fragrances you have. And so the concern, I will say, is just doubly there because by you smelling that stuff, you are dosing yourself, right? So it's one thing to care about the ocean and to care about the environment and care about things that are far away, but like your human health is right there in that. And that's essentially the answer that I have for you. It's like, what plastics should we be eliminating or reducing? It's plastics that in their production, in their manufacture, the people that are working on those and are exposed to those are being harmed acutely. When we're using them, we're being harmed acutely. I think fix that first, please. And unfortunately, there's a lot of stories you hear about composite manufacturing, composite materials. You can Google where this gets used, but the people making them, unfortunately, do not have maybe the same quality of life that we do working in a nice, sterile office.
I'm not a material scientist, but I think there are some typical types of plastics: polystyrene, polyethylene, polypropylene. It's really hard to replace polypropylene, those, the hard plastics you use for graduate cylinders or syringes. The polyethylene have the containers, like milk bottles, is also hard to replace. There's something that really got some nerve is the polystyrene, which is often used for packing materials. You can just replace with paper, and you save space. I mean, it's renewable. I don't need, because if you look at all this packing stuff, right, they use for, 3 days, 5 days, and they end up in trash can, last for many, many years. So paper will be a much better alternative.
So there's a framework in this space that people have approached this issue with, and it's UAP, unnecessary, avoidable, and problematic plastics. So, and it can be context sensitive, right? And it needs to be, because somewhere, and we talked about this morning, you might need, if you are going to get water outside your home, or maybe even inside your home, that water needs to be cleaned, and maybe it comes in a bottle, plastic bottle. You don't have a choice. But in another place you have access to clean drinking water, then maybe you would consider water bottles an unnecessary, or at least an avoidable type of packaging. So anyway, so many countries have looked at this. There is things called the Plastic Pact. So there's the U.S. Plastic Pact, and it's a list both of types of polymers, additives, as well as items like plastic utensils, I think, are on the Plastics Pact. Sometimes it's color of plastics, right? Because basically plastics are like paint. When you mix the colors, then they're fully mixed. So oftentimes you'll see recycled plastics being gray or black, but gray or black plastics are challenging. Because of that, they have less value. They're also hard if you're doing optical sorting, because black matches conveyor belts. So there's all kinds of, problematic plastics are problematic. Is it because we find more food wrappers, so are those problematic? Or is the color matter because of recycling, or plastic bags are super challenging in the waste management? Or is it the additives? I mean, those things need to be defined. But certainly I think for a country and a community, we have a lot that are unnecessary, and then avoidable, we can find alternative materials, and then problematic, specifically the toxins, need to be phased out.
Wonderful. So we're nearing the end of our discussion together, so I will close it with a question based on students, because we have students here with us today. So for students who care about plastic pollution but feel overwhelmed by the scale of the problem, what are the most meaningful actions they can take on campus, in their communities, or through their future careers to contribute to real change?
That's a lot of options. I mean, campus and then future careers. I mean, one thing I said at the end of my talk is that I think any discipline, I mean, probably we have mostly engineers here, but this is an issue that really anyone can help with. And I think another, I don't know if it's advantage, but the reason people know about plastics over PFAS is it's every day, it's the kitchen table issue, right? They experience it every day. And so that means both it's challenging because it seems ubiquitous and everywhere, but it does mean something that you can have an everyday action, can impact it, whether it be your choices. Although I know students are limited with funds oftentimes. I would say I love the advocate route, right? So if you see water bottles on a stage, you could be like, why are those there? Who should I talk to about that? How would I bring that up? Maybe there should be a policy. If you have time, right, you could do something like that. You can also communicate to companies. I mean, young people, I do think, have more influence than they realize when they communicate their wishes, especially to companies, and probably are more social media savvy than I to make their voices heard in that regard. So I think communicating to companies and government is a great route if you feel limited in your choices.
I'll build on that, and I think from the student point of view, I think sharing your values with the people around you, being part of a meaningful community, I think those are things you can immediately do. I was part of student organizations when I was a grad student, grad student government and things like that, and understanding what your friends, what your peers, what they're thinking, that makes a difference, and in SEEE, we have things that we do when we all get together and have a party, and it's because we listen to our students, because our students spoke up and said, actually, we prefer this instead of that, So for example, since as far as I can remember, whenever we serve food, there's always vegan options, there's always vegetarian options, and that was reflecting the values and the choices of the students. That wasn't something that could have been top down, and so I think continuing to engage with your community, I think, is the thing I would do.
Wonderful. Dr. Lee, would you like to contribute?
Well, I mean, I agree with everything that's said. It's just, you can make a difference in the way you walk, the things that you do, and people will notice that, and then you can voice things when you can. And I always think it's funny, I go to a lot of places, I give a lot of talks on PFAS, and I'll be there and I'll well, hold on, let me get my PFAS dose, because it's amazing to me that so many conferences and workshops can have PFAS in the name, and nobody made a single effort to have PFAS-free paper plates and paper and cups. And that's why I was giving somebody a hard time about the plastic bottle. I'm going to cover mine, because surely we don't want to promote plastic bottles. And I was telling Jenna, there's little things like, even when we traveled to Pakistan, I researched out how I could make sure my team was safe, because they do not have clean water there. And we were going there to measure their contaminants in their water, and they have a solid waste problem, and they have a plastic problem. So I didn't want to be drinking plastic, so I got everybody a bottle that would last at least 2 weeks for all the water they need, and would automatically filter out all the pathogens, and they were good. That's all we needed. And so we have choices. We can make better choices. Your voice matters. And I agree about letting people know when have you ever gotten something, it's in a sturdy paper box, and then you open it and everything's in a plastic container that you can hardly get open, and about cut yourself to get it open, and inside that everything's wrapped and sealed in some other material. So email that manufacturer, email Amazon and say, not happy about this, because eventually it can make a difference. So have a voice, be respectful and constructive, but you matter. Yeah.
Oh, that's great. I know we are in the university, we would like to talk about education, but I just want to mention some minor things we could do. The good old, principles, reduce, reuse, recycle, and if it takes decades of work to collect the data or implement a new rule or regulation policy, at least you can, or if we don't have a recycle program, at least you can reduce the use of plastics. For example, you don't have to replace your phone cases every 3 months, right? Simply because it looks nice. This collectively, this is going to build up, increase the overall impact. Just if it's not absolutely necessary, we could just reduce the use of plastics or indirectly contribute to this issue.
Wonderful. Well, I'm really glad that we were able to end on this advocacy and collective action note. I think that's really empowering for our students and all those who were here today and can watch this later on. So at this time, we have to wrap up our panel discussion, but I would like to thank all of our panelists, including Dr. Jambeck, as well as our audience members for engaging, and I'm glad we were able to have a great discussion today. Thank you also to all who played a role in helping realize this event. Thank you.
Thank you.